everyone. So today's lesson is on segments and their measure. And we're going to be talking about a lot of different things, but hopefully you have already done the warm-up. This asked, where do planes KLMN and plane QRML intersect? And remember, intersect also means meet. Where do they meet? And we know from our last lesson that two planes intersect or meet in a line. So I'm hoping that you found that line MLM is where they meet. Now, as a reminder, you could have used shading, or you also could have just looked at the planes here because they were given to you in four letters. You could see that the overlapping points actually were where they meet. All right, but today's lesson is actually on distance and segments. So first we're going to talk about distance on a horizontal number line. Let's remind ourselves that a horizontal line is a line that goes from left to right. I always remember horizontal because I think of the horizon and the sun shining from off the horizon. If I'm standing at the beach and I'm looking at the sun rise, the water actually creates a horizontal line. So that's how I always remember it. Whereas a vertical line goes up and down. Okay, so this is a vertical line. And this is a horizontal line. All right, so we're going to be talking about finding the distance on a number line. How do I ask you to find distance? Well, like we've talked about, there's lots of symbols that we use in geometry that kind of are distinguish what we're actually looking for. So let's review a few, okay? So over here to the right, let's make a little box and let's recap. If I'm going to ask you for segment PZ, I'm going to just say PZ with the segment. I'm only going to name segments like that. That's a segment. If I was looking for ray PZ with the endpoint being P, I would put the ray symbol above it, and that means ray. Okay? If I was talking about line PZ, which means it goes on forever, I'd have to have that line symbol with the arrows on both ends. But now we're going to be talking about how do we find the length. When we're trying to find the length, we actually don't use any symbol. We would just say, find PZ, okay? So if I just write PZ with no symbol, it means I want the length or the distance between the 2 points. So this means find the distance between the 2 points. All right, so we investigated this a little bit in class today, but let's talk about that. PZ, I want to find the distance between P and Z. Well, yeah, I'm looking at a number line, and I could just, if I wanted to, count 1, 2, 3, 4, 5, and see that it's 6 units. So PZ is equal to 6, and that's distance is 6. And we know that distance always has to be positive. Well, in class, we did some things with finding the difference. So let's do that. Let's find the difference in the numbers, in the coordinates, and the distance, and see how they compare. Okay, see how they compare. All right, so if I do the distance, I could do -1 minus 5. So -1 minus 5 is actually minus 6. But the distance is 6. Well, I could do it the other way. I could do 5 minus -1. That becomes 5 plus 1, which is 6. So is that the only way I can do it? Well, if you remember from class, we talked about the mathematical operation that we could use if we got that -6. Remember, to make a negative value positive, we take its absolute value. I'll take its absolute value. And that would give me that distance of 6, okay? All right, so let's talk about that as a concept, though. How could we always get to that positive answer without having to do the absolute value? Well, if you think about it, if you think about this as the left coordinate, the P, because it's on the left side, and if we think of this as the right coordinate, let's think about the method we use to get to the 6 directly, this one. Could we say do the right coordinate minus the left coordinate. That is a method that will always give you a positive answer. So that's one way of thinking about finding the distance on a number line. All right, so now I'm not going to give you a number line. So I'm going to give us some practice. So I'll do the first one with you. So I didn't give you the number line. Oh my gosh, what am I going to do? I want us to find the distance between -3 and 8. So first I'd like to picture that. So I need to know that -3 is on the left side of the number line and 8 is on the right side of the number line. So if I use that concept of left minus right, or right minus left, like we did here, right? Right coordinate minus left coordinate, then I could do 8, so the bigger number, 8 minus a -3, that gives me 8 plus 3, which is 11. All right, now I am going to draw that for you a little bit, just so you can see. If I'm at -3 here, I always relate it to 0, because it's really easy for me to see how far things are from 0. So I can see now that from -3 to 0 is 3 units, and from 0 to 8 is 8 units. I add them together, and that is a total of 11 units, okay? All right, so I want you to press pause, come back, and I want you to try 2, 3, 4, and 5, and then I'm going to give you the answers. So press pause. All right, so now you've done those the next 4 problems, and hopefully you got answers of the first. Number 2 was 5, number 3 was 4.4, number 4 was 17, and the distance between 12 and -1.5 was 13.5. All right, so just remember, we did right coordinate minus left coordinate. If you got any of those wrong, I want you to think back to that again, see if you made a calculation error, and then if you still aren't sure, bring a question to class tomorrow for us to talk about, okay? All right, moving on. Our class, geometry, is going to be made up of a hierarchy of different things. The bottom of the hierarchy is what we did yesterday in 1.2. Points, lines, and planes, okay? Points, lines, and planes lead us to make conjectures about things, which then leads us to our postulates. A postulate is a statement accepted without proof. A statement accepted without proof, meaning I'm going to tell you something, you're going to believe me. You're going to accept it to be true. Your mom and dad told you that when you were a little kid that the sky was blue. The sky was blue. Well, you just assumed it was blue because they told you to, and you had to believe them. That's a postulate. A theorem, though, must be proved. And our class is going to be talking about different ways that we can prove things to be true 100% of the time. If it is a theorem, it has to be proved 100% true all the time. All the time. Okay? All right, so we're going to talk and learn our first theorem. Our first theorem is called the segment addition postulate. Okay? The segment addition postulate says that if you have a segment, so here's some segments. It's also a line, but we know that their segments are on lines. And B is between A and C. So it's in somewhere in between. It doesn't necessarily mean it's in the middle. If B is in between A and C, then AB plus BC is equal to AC. Okay? So the distance from A to B plus the distance from B to C is equal to the whole distance. And what I like to think about when I'm thinking about the segment addition postulate is that the sum of the parts equals the whole. The sum of the parts equals the whole. Now, the same can be true if I flip that around. If AB, let me erase that. If AB plus BC equals AC, then I know that B has to be between them. As long as a diagram is given to me and I can actually say that by the segment addition postulate that B would be between A and C. All right, so now let's kind of put this together, okay? All right, so here I give you an example, and it says that RS equals TU. That means that they have the same length. Equal means the same. So their distances are the same. When we want to indicate things in a diagram in geometry that are equal, we use something called a hash mark. A hash mark, okay? Hash marks are used to indicate equals. So I can put a hash mark here, RS. Actually, I need you to change the A to a U, okay? And that would mean RS equals TU. So those two are equal. I also know, I want to mark the diagram with what they gave to me to start with, that ST is of length 9. So I know that this segment right here has a length of 9. Okay? And RU, the entire segment, is 33. All right. So how am I going to find RS? All right, well, you have a couple of options. You can use algebra, or you can just use mathematical thinking. I'm going to do both. All right, if I wanted to use algebra, I would give RS a variable, because remember, algebra involves variables. So I'm going to call it X. If this is X and they're equal, then I can make this X. Then I could write an algebraic equation to solve for X. Because the sum of the parts equals the whole, the segment addition postulate tells me I can say X plus 9 plus another X has to equal 33. That gives me 2X plus 9 equals 33. And I would subtract 9 from both sides, getting 2X equals 24, and therefore X equals 12. So that's using algebra. Using mathematical reasoning or thinking, what I would probably do is do 33 minus 9. Get rid of that, and I get 24. And then I know that those two additional segments were equal. So I'd have to cut 24 in half. So 24 divided by 2, which gives me 12. Either way is a proper way for solving this type of equation. Okay, so now we know that RS is 12. Then it says to find SU. All right, so I'm going to put it 12 over here for X. SU is 9 plus 12 because it's ST plus TU equals SU, segment addition postulate. So giving me SU is 21. All right, let's try another one. Given. Now notice the word given here. I'm telling you that Y is between X and Z. Y is between X and Z. So I'm actually going to draw a picture. Anytime you are given some information and it relates to a segment or any diagram and we don't have one, I want you to draw the diagram. So I know Y is somewhere between X and Z, not necessarily in the middle. It says find the distance between points X and Z if the distance between X and Y is 12 units and the distance between Y and Z is 25 units. Okay, so if I want to find the distance between X and Z, then I can use the segment addition postulate. The sum of the two parts equals the whole. So 12 plus 25 is going to equal the whole segment XZ, so 37. You really want to draw an accurate picture there, okay? All right, last thing we're going to do is we're going to talk about congruent segments. So here's another word. Congruent is just another word for equals. So if two segments are congruent, then they have equal length. They have equal length. The symbol that we use for congruent is that funny looking, like it's an approximate symbol over an equal sign. So again, congruent. Okay, if two segments have equal length, then we're allowed to say that then they are congruent. Notice that I just flipped those statements around. If they are definitions, then I'm allowed to do that, and it should work either way. All right, so here's an example. If I give you a segment like this, A, B, and D. Okay? If AB equals CD, remember I use the hash marks to say that they're equal, then I know that segment AB is congruent to segment CD. So this is a statement I'm allowed to make about them, a geometric statement using the term congruence, okay? All right, so let's just practice that a little bit. So on the next example, next page, if AC is congruent to AD, then AC is equal to AD. And if DE is congruent to AC, then DE is equal to AC. All right, guys, so we're going to stop there. This is part 1 of section 1.3. I am going to have you do part 2 as well. It's a shorter video. So take a break for a few minutes. Go on to something else and maybe go back and watch the last maybe 5 minutes of your video. So part 2. Have a great night.